One of the strengths of Petrosys is that we're an E&P industry-aware software package with great connections to common E&P interpretation systems. So through launching the Petrosys Grid and Contouring module from within Arc, employees of Company X were able to utilise Petrosys Grid and Contouring volumetric capabilities and direct connectivity natively from within their preferred GIS environment. So if we have a look at the workflow Company X was using, we can see that they're doing a number of different tasks which involved accessing data from disparate data stores. These data stores are disparate because they had no direct connections to each other and maybe on different operating system platforms. So if I open up the first task and have a look more closely at the input data, we can see that this task was gridding seismic data directly from an S&T project, but Petrosys gives you the ability to access a number of different data types and data stores. So as well as accessing this data from an S&T seismic data store, they could also access well data from all the different sources that you can see on your screen. These include some major interpretation packages like, major data stores including Petrel, Geographics and Geoframe. But importantly, they could also access spatial data in all the formats you can see on your screen. If we go back to the gridding panel, we can see why Company X was keen on using Petrosys surface modelling. Basically, they found that they had full control over the gridding process, including the ability to choose a range of gridding methods, as you see there, include Kriging and trend surface method. They could also incorporate faults from third-party data sources. They also like the fact they could combine multiple data sources in multiple CRS in the one gridding job, as Petrosys would handle all of the coordinate conversion itself. So if we return back to the workflow, I'm just going to go to the last task here. Another aspect of the grid and contouring functionality which Company X found useful was the spatial data translator, which they used to export spatial data into GIS formats. This example here is you taking a Petrosys contour file and writing it out to shapefile, whilst incorporating a coordinate conversion. There are a number of different input data source types, as you can see here on the screen, including all our proprietary Petrosys formats, as well as these third-party ones you can see down here. For output data sources, you can again output to our Petrosys proprietary formats, but they're also available are shapefiles and, interestingly, KML files, which are for use with Google Earth. So, as well as having that range of import and export formats, using the spatial data translator and gridding allowed them to batch process these export tasks. The other area that the spatial data translator is available is plus using it interactively from a map. So if we now run the workflow that the Company X was using, we can see that Petrosys runs through each of the tasks, effortlessly creating time velocity surfaces from S&T and SizeWorks, and then depth converting them using Petrosys Grid Arithmetic. It then ties this depth surface to wells held in a Geoframe database and produces a volumetric report on the tide depth structure using specified contact levels. Finally, it writes the contour file out to a shapefile whilst performing that coordinate conversion we talked about. So if I bring up, there's our volumetrics, our slice volumetrics output. A quick mention about task lists in a GIS context. One of the reasons Company X liked using Petrosys was they could incorporate subsurface workflows with their GIS environment. Task lists allowed them to save their workflows and run them multiple times should interpretation be updated or well picks changed. This was a major time saver as their GIS maps could be updated in minutes, as you saw there, rather than hours. So once you've run the workflow, you can access the outputs directly from your ArcMap GIS. So direct display is really powerful for Company X as it allowed both GIS the G&G teams to display their Petrosys workflow outputs in their GIS environment as native objects. So as you can see here, just look at how easy it is to drop these items onto an ArcMap canvas. To be able to get these same items onto their GIS maps before, Company X had to export them in ASCII format, manipulate the ASCII formats, and then import them into Arc, which took a lot of time, not to mention the associated risks of introducing errors. So using Petrosys has significantly reduced the time between data creation and mapping, as you've seen here. As I mentioned, these objects are native Arc objects, and as such, you have full control over them as you would any other, as you would have with any of your other data in ArcMap. So we can change, obviously, the color gradient there. With contours, you can change the contour level and the style of line, etc. All these items appear spatially correct in ArcMap because each of the Petrosys file types contains CRS information which can then be read by Esri. So far we've seen how Company X used the Petrosys plugin for Arc to interact directly with their GIS environment. However, Company X found that they could also utilize some other functionality within Petrosys to add value to GIS workflows. So another way in which Petrosys acts with the GIS environment is through the use of web map servers. For those of you who've never heard of a web map server before, basically it allows users to publish their Petrosys map layers to a server, which will then allow these layers to be accessed by other software, including GIS systems. So in Company X's case, this was particularly useful as we have on screen. They had many legacy Petrosys maps, which include layers displayed directly from interpretation systems or data stores not accessible by their current GIS environment or other offices that weren't running Petrosys. So as well as having our depth structure, faults and contours that we saw before, we've now introduced some well data coming from our Petrosys PPDM master well data store, as you can see here. All the objects in the Petrosys map are fully interactive. And we've also got a 3D bin grid being displayed directly from SMT. So what Company X would do would be to publish the map to the WMS, and then they could then access this data across the internet. You could even do it in a web browser. But if we connect to that WMS server, ArcMap's just currently accessing the server that I've saved the map as. If I just expand the layers here, you can see that it's not just a simple image that's been served up here. We're actually introducing all of the layers from the Petrosys map that you saw. I can prove this by turning on and off particular layers. The problem is it's got to go back to the server and redraw, the layers that we've requested. But as you'll notice here, we've incorporated data from our master well data store and a 3D bin grid from SMT that were previously unavailable, or certainly unavailable with this level of simplicity to the GIS environment before. So you can share data with your GIS teams that have never previously had seamless access to this kind of data. It also allows you to share data with other offices and management, and often teams in the field, as this data is served up in an easily digestible form by the fact you can access it through a number of software packages and even a web browser. So I'm just going to return to my Petrosys map, and I'm just going to show you here how the spatial data translator can be used interactively from within the map environment. So if I display some 2D navigation from an SMT project, I can interactively select that item, whether it's from the display list or from the map, and I can right mouse button and export that spatial data. So I can export it to a shapefile here, or you can also export it to some Petrosys formats or KML for use with Google Earth. I'm just going to overwrite a shapefile I've already created. That's literally taking about 2 seconds. If I return to my Arc map, I should then be able to just add that shapefile in. As you can see there, the real value of that was that in a matter of seconds I've added data to my map that was previously inaccessible to the GIS environment, and it's also in a format that I can share with other people or any software package that can read Esri shapefiles. The important thing to notice though that is, whilst we did this with line data on this map, any point, line or polygon data that you're displaying on your map, regardless of data source, can be exported in this manner. So you could have wells from geoframe or Petrel, seismic navigation from SeisWorks, etc. If I just go back to my PowerPoint here. So just to summarise here, GIS staff were now free to spend more time on environmental and engineering projects. As we saw before, the GIS staff were bogged down doing ASCII file transfers and data reformatting, but now they can connect directly to their data stores. This is no longer a problem for them. All the CRS their data is handled automatically, removing their previous fears regarding the CRS integrity of their final maps. G&G staff now have more control over maps which they were previously detached from, and all of this leads to substantial time saving from a data management point of view. Company X has told us that through introducing Petrosys to their GIS workflows, they've seen up to an 80% reduction in their mapping cycle. And GIS users were able to use powerful Petrosys gridding, which was something that was not previously accessible to them. The next steps, if you wish to contact us, you're more than welcome to try out the Esri plugin and WMS server. You can contact us on the email address on screen, or we can have a chat after the webinar.